Hi, everyone. Today you are going to be learning about solving systems of quadratic equations. This is the first lesson in our Unit 3 extension. When I come back tomorrow, we'll go over the calendar a little more in depth so you can see where we're headed. But we're going to be spending some time learning about quadratic equations in ways that are either like word problems or things you can do on the calculator or on Desmos. So a little bit extra that we didn't do in the main part of the unit. So today you're going to finish watching this video, copying down the practice problems onto your sheet there in front of you, and then on the back is your homework. So the back of that sheet is homework. And then before you leave, you're going to need to make sure that you finish the system of equations that you're going to solve by hand that you may check using Desmos. So don't forget to turn that in before you leave. Okay, so when you go to solve a system of quadratic equations, you're going to have really two ways to do it, either algebraically or with Desmos. And sometimes you can use both and kind of use them to check each other. When you solve a system of quadratic equations, so something that looks like a parabola, right? You have the same methods as lines, which would be substitution and elimination. You're probably going to use substitution most of the time because most quadratic equations are written as like y equals, and then they have your x squared on the other side. And since both of them are written that way, you're usually going to just set them equal to each other, and that method is substitution. Elimination is usually a lot harder. When you solve a system of equations with Desmos, you're basically just going to type each equation into a separate line on Desmos and then look for the intersection point on Desmos. And it might require you to zoom in or zoom out a little bit, but that's all there is to it when you use Desmos. So we're going to practice 4 problems algebraically first, and then I'll show you how to solve them all on Desmos as well. Okay, so here's the first system. This is actually a quadratic equation that's sideways. So it's like not normally opening up or down. This is actually opening to the left. And then this is a line. And notice how they're both x equals and x equals. So of that, we are going to set these two equations equal to each other because we have them both for x equals. So negative y squared minus 3y plus 2 equals y plus 6. And don't forget, if you need to spend some time copying stuff down, just pause the video, copy it down, and then start it back up. Okay, so after you do this, you're going to move everything to one side and solve it just like you would a normal quadratic equation. So I chose to move everything to the right, so I added y squared to the right, I added 4y to the right, and I subtracted 2 to the right. So y squared becomes positive, 1y plus 3y is 4y, 6 minus 2 is 4. And then once I get to there, I'm just factoring. So y squared plus 4y plus 4 turns into y plus 2 times y plus 2. Well, that actually creates the same value twice. So you get y equals negative 2. So you only have one place where this is going to cross, and that's at y equals negative 2. And then the big piece of it, the kind of the last step here, is you need to make sure that once you find one of the values, so here's my y value of negative 2, you substitute it into one of the equations from above. I chose to substitute it into this one because that's easier to work with. You could also put it up here and you would get the same answer. So your final is 4 for x and negative 2 for y, and make sure that you are writing it as an ordered pair. You will have the possibility of 2 values as well. So there's a possibility that you'll have 2 answers. All right, so here's the second one. This is also a quadratic and a line. So this one has x squared by itself on the left side and then y minus 1 here. And then so that's your quadratic. And then this one is a line. It's y equals mx plus b. So just like before, this is going to be a little bit easier to do with substitution. So hopefully you can see that I took all of this and I am substituting it into the y portion of the equation above. So 4x plus 1 went in for y, and then there's my minus 1 that's left over. Okay, so for this problem, what ends up happening is let's go like this, is the ones go away. And so I've got x squared equals 4x, so I'm going to move the 4x to the left. So I subtracted it to the left, so it's equal to 0. So that's my first step. And once I move it over, then I'm going to do some factoring. Okay, and solving algebraically, we're hoping that it's factorable. It'll be a little bit easier. So here's my factoring. It's a GCF factoring right here. And then don't forget, when you have x by itself, that answer for that value is just 0. So I end up with 2 values for x here. I get x equals 0, and from this part, I get x equals 4. So once I get those 2 values, I have to sub each of them in to one of the equations from above. So I chose to substitute them in to the second equation, again, because that one's easier to work with. So 0 went into y equals 4x plus 1. That's the one we're using here. So I put 0 in for x. I get 1 as my y value, and then I'm going to write it as an ordered pair. So one of the intersection points is 0, 1. And then I'm putting 4 in for x here. So 4 times 4 is 16, plus 1 is 17. So that means my second ordered pair is 4 comma 17, because when I put 4 in for x, 4 in for x, I get 17 for y. So there's my 17 for y. So 2 answers. This line crosses this quadratic equation twice. All right, number 3. Now I have, again, a quadratic, normal quadratic, and then a normal line. So again, you can see it's just y equals y equals. So you're kind of, again, in a better place to just do substitution, where you substitute like this part here in for this y, or the other way around, doesn't matter. So you can see that what I wrote down here was x squared minus x plus 3, and for y, negative 2x plus 5 is what the other y was equal to. And now you're just solving this quadratic equation just like you've learned how to do already. This is something you just finished in the last test. So we're adding 2x to the left, positive 2x, negative 1x becomes x. Subtract 5 to the other side. So when you subtract 5, okay, so you can see that, 3 minus 5 is negative 2. So I get to this spot here, x squared plus x minus 2 equals 0. And now I'm factoring, right? So when I factor this, I get x plus 2 times x minus 1. And when I take each of those values and I set them equal to 0, I get 2x values. I get x is negative 2 and x is positive 1. So just like before, on the last problem, we're going to take each of these x values and I'm going to substitute them into one of these equations. And I'm going to try and choose the one that I feel is easier to work with. Maybe you like squaring stuff. Maybe for you that's easy, so you want to choose the top equation. But I think that substituting into the line is going to be easier than the quadratic. So I'm going to put negative 2 in for x there and 1 in for x. So here's my work for that. So I'm, again, putting my x values that I just found into this equation, negative 2x plus 5. So put negative 2 in here. I get negative 2 times negative 2 is positive 4. Positive 4 plus 5 is 9. And so I write that as an ordered pair because x is negative 2, and that gives me y is 9. And the same thing for the second one here. I'm putting 1 into my equation. So negative 2 times 1 is negative 2. Negative 2 plus 5 is positive 3. So my point is 1, 3. Again, I hope you're taking advantage of being able to pause if necessary. Okay, here's number 4. So this one is actually 2 quadratic equations that you're going to set equal to each other, again, because they're both y equals. You could do this with elimination. I think if you took like the top equation and multiplied it by negative 1, you could, sorry, I want to make sure that's not the way I did it, but you could multiply like this top equation by negative 1, and that would allow you to get rid of both the y's and the x squareds, and you would just have x there. So this one would actually work fairly well with elimination, but I believe I still did this with substitution. So let's see what I did here. Yes, I did substitution. So I took this equation, or this part here, and I substituted it in for this y here. And so that's where I get x squared minus 2x plus 4 equals x squared plus 3x minus 6. And now I'm going to move everything to one side, or at least all the x's to one side, so that I can solve for my single x term. So I'm going to like subtract x squared to this side, and that's why I've crossed these off, because they cancel each other out. And then you're subtracting 3x from both sides, and so negative 2x and negative 3x gives us a negative 5x. And then I'm going to subtract 4 to the right side, so subtract this 4, subtract this 4. Negative 6 and negative 4 is negative 10. So I now have negative 5x equals negative 10, which gives me, when I divide by negative 5, x equals 2. So I only have one value for x. So to figure out what the y value is, I have to substitute it in. And it's not super easy because I'm dealing with the quadratic. So I chose to substitute it into the bottom one. And I chose that personally because I had a positive here in front of the 3. But you can, again, choose the top one, and you just have to be careful with the negative sign. So I'm taking that bottom equation, so y equals x squared plus 3x minus 6, and I am substituting 2 in here and in here. So I'm doing 2 squared is 4. Then I'm doing 3 times 2, which is 6, and minus 6. So 4 plus 6 minus 6 gives me 4. I'm going to write that as an ordered pair, and I get 2 comma 4 as my answer. Okay, now I'm going to show you how to do all of this on Desmos. So I'm going to show you the graph of it, and then I'm also going to just like type just one in so that you can watch me do it. But Desmos makes it really easy. So before let me just show you the picture first, and then I'll show you how to type this in. So you're going to Desmos, and the Desmos link is just desmos.com/calculator. I actually have mine bookmarked. And you're typing in right here, and it doesn't matter if it's x or y. So if you have x equals y squared, it's going to type in this sideways parabola for you. It's going to make it look just exactly like what it needs to be. So you can type in literally anything you want here, and it'll work for you. So when I typed it in, here's the first equation. And so in the first line, negative y squared minus 3y plus 2. And the second equation is x equals y plus 6. And so when you type those in, you just have to click on the spot. I'm going to bring this back over here so you can see it. You just have to click on the spot where the intersection is, and that's it. Like, that's all you have to do. So let me bring the actual graph over. So here it is. You can see the intersection spot. Just click on it. I don't even have to click on it. I just have to kind of click on the line. So you can see once I click somewhere on anywhere, the points show up, and there it is, 4, negative 2. There's the vertex, by the way. You don't care about that, but there it is. There's the intersection. So that's all you're doing. Okay, so there's number 1. Number 2, typing them in, again, just the way they are. X squared equals y minus 1, and y equals 4x plus 1. And you need to make sure you look carefully for where the intersections might be. So it might require you to zoom in and out a little bit on the graphs to be able to see them. Like 17 is kind of big. So being able to find that, you have to look a little bit for it. Zoom in and out. And to zoom in and out, if you remember, you just take the little plus or minus buttons on the right-hand side of the graph and just hit them until you can see what you need to see. So zoom out as much as you need to. That was number 2. We already know the answer, so we're just seeing them on Desmos. So here's number 3, negative 2, 9, and 1, comma 3. And then number 4 was just 2, comma 4. So there's all of the graphs. You can see the graphs and the shape that they take on. So hopefully that all makes sense. Make sure you pick up the exit slip to turn in before you leave, which is practicing in both forms. And I'll see you tomorrow.